What are some of the challenges with scleral lenses? Well, we've talked about conjunctival inflammation, and we've talked about conjunctival impingement and blanching. These are controlled by manipulating the peripheral curves of the lens. Bubbles and mucin entrapment on the lens can be a problem. I find that bubbles are always a problem with application of the lens to the eye. Improper application results in bubbles. You have to tell the patient to be patient, and if they have a bubble, they have to remove the lens and replace it. Mucin entrapment is another thing. Some patients have high mucin content in their tears, and as the tears flow under the lens, we can get entrapment there, and as the amount of mucin builds up under the lens, it can actually affect vision. What we advise our patients to do in that case is to remove their lenses, flush the eye, flush the lenses, put the lens back on. What happens with pterygia and pinguicula? Well, we want to avoid them. So we either fit so that we don't go up to them or we fit beyond them. Conjunctival billowing and chalasis. They may be a problem. Probably they aren't. But that's something that requires vigilance on the part of the practitioner to ensure that there are no problems developing. Limbal engorgement, that's a tight periphery. We have to loosen up the periphery in that segment of the lens. And remember, we want to keep our patients in the proper solutions. You want to tell the patient the exact solutions to use and ensure that they're using them. It's not unusual for a patient to want to save some money, and they'll buy some preserved solution. They'll come in with a slightly red eye, and when you put fluorescein staining on the conjunctiva, after you remove the lens, you're going to see that they've got a solution-created toxicity or staining pattern. Now, the most important thing for the patient is to be comfortable removing their lens. And what happens if they forget their suction cup or their lens remover? Well, this can be very difficult because these lenses are very difficult to remove without the appropriate types of devices like the DMV remover. So I always give my patient several suction cups, several lens removers, and tell them to make sure they keep them in their purse or their pocketbook or with their computer, and especially when they travel. And now a tilted lens, when it's on the cornea, tilted in reference to the corneal plane, will cause some residual cylinder. And so you might find that there are times when you get better vision with a corneal lens than you do with the scleral lens. And that's due to the residual cylinder that's not corrected due to this mismatch of the two surfaces. It's been my experience that comfort trumps vision. And so that the patient always prefers to have the more comfortable lens and is willing to wear an overcorrection in glasses when the cylinder or the astigmatism correction isn't fully corrected by the lens itself. So I am going ahead and fitting my patient. And when I'm fitting the patient, I want to document what are my clearances. And here my estimations were maybe a little on the low side. But if you look at my drawing here or my figure, you'll see that we have a lens on the eye, and I've estimated the tear lens depths at various positions. And if you look at the actual reflection of light off of the front surface of the lens, you'll see just to the left of the 350 number, you'll see the front surface of the lens. Then you'll see a very thin dark line or zone. That zone is the plastic of the lens. If this lens had a thickness of 0.30 millimeters or 300 microns, then that is the thickness of the lens at that point. That is my yardstick for being able to evaluate how thick is the fluid layer behind it. The fluid layer is, if we start on the right again, we have the bright reflection off the front surface of the lens. We have the black band, which is the plastic of the lens. We have an internal reflection coming off of the inside surface of the lens. We have the fluid, which is a little murky looking. And we have the cornea, which is that bright gray band to the left. If I follow that band from superiorly up around that 350 mark down to that 25 mark, you can see that there's a change in the depth of the fluid between the lens and the cornea, and that's due to the shape of the cornea itself. Here we have a sagging cone that we're vaulting over. And so let's look in real time as I evaluate the tear layer. What I do is I go from limbus to limbus, and I want to look at what I'm not quite going far enough over to the limbus. I'd want to go all the way over to the 3 o'clock and back over to the 9 o'clock position. But as I go back and forth, what I'm showing you here is that there is a variation in the depth, and you should document that. The importance is if you need to change the lens in the future, you know what type of clearances you were dealing with. Here we can see with fluorescein a more obvious fluid layer. Again, looking from right to left, we have the reflection of the light off the front surface of the lens. We have the dark band, which is the lens itself. We have the internal reflection. Then we have a green fluid tear layer or fluid layer. And from there, further left, we have the gray band of the epithelium and the stroma of the cornea. And as we look, you'll note that the tear layer is thicker or wider, usually inferiorly than superiorly. Here we have a lens that maybe I could decrease that profile curve to decrease the mid-peripheral thickness of the fluid layer, but as I go over nasally, my tear layer gets very narrow. So I really judge my fitting on the narrowest zones, and do I have proper clearance? So that's why we can have a variation in thickness. Here you have a fairly thick tear layer, maybe 500, 600 microns inferiorly, and we have a fairly thin tear layer when I went nasally and temporally. So there's a variation. So you don't just look at one place on the cornea and judge your clearance. You have to judge from limbus to limbus. When we decide that the 15.8 millimeter diameter lens is not the appropriate lens and we want to use an 18 millimeter lens, we have two choices. We can try to use the fitting set, but we'll have to make some adjustments. Or we can actually call Blanchard and ask for a loaner 18 millimeter set. If you like the 18 millimeter diameter, you may also want to purchase an 18 millimeter set to put in your fitting library. Now let's look why the 15.8 millimeter lens and the 18 millimeter lenses don't fit exactly the same. Here I have drawn a 420 SAG 800 profile or increased profile 15.8 millimeter lens on the screen. I'm going to superimpose over that a 420 SAG 800 profile or increased profile 18 millimeter lens. And let's look at the difference. The difference is at the base of where the 15.8 millimeter lens is, you'll see the chord diameter is greater in the 18 millimeter lens. So that lens is going to actually fit lower onto the cornea. It's going to fit further back on the sclera. So we need to have an increase in the sagittal height of the lens if we put that lens on the eye. Here, we think that the 430 SAG or 100 micron increase in SAG will adjust for that change in this, the chord length at that 15.8 millimeter mark. We need to put the lens on the eye to see if this actually happens. And it's like putting a larger hat on your head. The larger hat is going to fit lower, around covering your ears perhaps. So as we put the lens on the eye, the 18 millimeter lens fits further back, and we might have lost the vault that we want or the clearance that we want from limbus to limbus. So this necessitates a higher sagittal height lens. Also, I might note that as we go further away from the limbus, the sclera actually starts to lose some of its symmetry, and actually I would prefer to fit with a trial lens set. So I would ask for the 18 millimeter lens set for use when I'm trying to fit the larger diameter. Now, let's understand how the conjunctiva responds to the presence of a rigid lens. First off, we can have what's called conjunctival chalasis. This is a benign finding. I'll show you examples of where the conjunctiva is pulled in beneath the surface of the lens and billows at the limbus. The lens compresses into the conjunctiva, and this leaves behind what's called a compression ring. It's like when you're wearing a sock that's tied around your ankle and you take it off and you can see the imprint of where the sock was. If this goes away within 15 minutes, and it usually does, it's of no consequence. If we have conjunctival injection from lens wear, this should be addressed. And if we have injection after the lens is removed, but we didn't have it before we removed the lens, this is usually short-lived, and we see this with some of our patients. They have a very finicky conjunctiva that's easily irritated by removal of the lens, but it's a short-lived problem. This is an example of conjunctival billowing or conjunctival chalasis. Different practitioners call it different things. What happens is the conjunctiva is loose and it is drawn in with tear exchange under the lens, and we see a ballooning of the conjunctiva at the limbus. When the lens is removed, this goes away. So it's really a benign finding, and we don't think it's of any consequence. However, if you do have conjunctival staining in this area when you remove the lens and the stain remains, then that's an area that we should address, because remember, this is where the limbal stem cells are located, and we want to make sure that we do protect those cells. This is an area of inflammation. Notice that we have a tight periphery. You can see that bright white band. But if you look at the appearance of the conjunctiva adjacent to the limbus versus outside of the lens, you'll see that we have a more pink, congested area, and this indicates that we have too tight a periphery. Just flattening the periphery in this instance is going to alleviate this problem. This patient has a compression ring. When I remove the lens from the eye, I quite often find a compression ring. Compression rings are usually a benign finding, and they dissipate within 10 or 15 minutes. This compression ring is slightly different. You see that there's conjunctival staining from fluorescein where the compression ring was. This lens might need to have the edge of the lens modified or polished by the laboratory in order to create a smoother juncture. Not all patients are symmetrical. This patient has a conjunctival bleb, almost like a chalasis, nasally, and we're getting a great deal of congestion there. Now, this patient, surprisingly, isn't bothered by this and comfortably wears his lens 14 to 16 hours a day. However, I'm not comfortable with it. We were able to alleviate this problem entirely by going from a 1-flat to a 2-flat peripheral curve system. Here's a patient that has had his lens removed, and you can see that the imprint of the lens in the conjunctiva is still there. The area of the limbus shows a slight amount of staining. This is something that should be addressed. A change in the fit in this instance was actually to, again, flatten the periphery to the next flatter zone. This patient was wearing a standard design peripheral curve. We went to a 1-flat, and we were able to get a better alignment in the periphery. Also, we increase the sagittal height of the lens to get a little more clearance at the limbus. Thank you for your attention today. I'd like to add 2 things. First, go to the Blanchard website if you need to access the fitting tool available for the MSD lenses. It will allow you to easily make adjustments in your fit and not make mistakes in your lens order. Second, if you have questions, don't hesitate to call the laboratory consultants that are available at Blanchard. They can help you out. They fit these lenses with practitioners every day. Again, thank you for your time, and I hope you enjoy fitting the MSD lens.